Alright guys, let's geek out today about some brackets. Great question sent to me by Marcus. Thank you so much, Marcus, for asking this question. Let's talk about brackets. Now, for the purposes of this, I know the difference, but I talk about brackets in a weird way. A soft bracket is a parenthesis, really, okay? Parenthesis. I know that, but I call them soft brackets from time to time. And a hard bracket is literally a bracket, alright? So don't get too kind of thrown out, but soft brackets here, hard brackets here. So that's just a bit of my notation for this, all right, before we get started. Um, and so it begs the question, when can you use what? What do you do when certain situations are given to you? And let's just look at an example. Here we're going to talk first about interval notation. So in interval notation, we have to have brackets of some sort, right? Notation. So let's look at the interval 3 to 4. Sorry, let's go negative 3 to 4. Okay, so what this means is that the soft bracket here indicates that negative 3 is not part of this interval. So if we were to list all the answers in using the roster method, I would list negative 2, negative 1, 0, 1, 2, 3, and 4. Those are all my answers. And 4, because there's a hard bracket here, means that we include 4 as part of this interval. We could also get kind of crazy with, I'm just listing integers there, but you could list decimals too, or any rational number. So negative 3 is not part of this interval, but negative 2 decimal 99999 repeating, that is part of this interval. Okay, so we can get pretty precise. We're not going to get that precise in this course, but if you're studying calculus, definitely you want to get to that level, right? So that's the first kind of way when we use brackets. If there's a hard bracket, it means that that is part, that number, that endpoint, whatever it is, that is part of the interval. So you get a hard bracket when it's part of the interval there. All right, now in general, that's using interval notation. What happens then if we're asked, say we get a function, some weird function like, I don't know, let me just pop into Desmos here and graph one. Alright, so here we have f of x equals x cubed plus 2x squared plus 1. I just made this up off the top of my head. But if we're asked questions about over what intervals is this function increasing, decreasing, or constant, then we could just use soft brackets, parentheses. Okay, we don't got to get carried away because we're kind of generally just describing the graph. So in this function, if we pretend we're right here, let me get rid of this keyboard so we can see what's happening. If we pretend we're kind of walking up this graph left to right, we can see that it's increasing up until this point right here. So it's increasing from the most negative number, which is negative infinity, all the way to this point here, which is negative 1.33, or just negative 1 1/3. Okay, again, I made up that number. So it's increasing from here to here. So the intervals it's increasing from are from negative infinity all the way up to negative 1 1/3. Then it's also increasing from this point, 0 on the x-axis, all the way to infinity as well. So we just use soft brackets there. We're not getting too crazy with the endpoints and all that stuff, okay? Because we're just describing the graph. This graph is also decreasing from the interval, by the way, from negative 1 1/3 to 0. So this interval right here, it's decreasing. Now, let's check out a bit of a different example. Let me go with x squared. Let's do something like just the old standard parabola. Okay? So here, if we're talking the domain of this parabola, it's all real numbers from negative infinity to infinity, because this is going to just keep going. If I zoom out, we can see that it's not stopping and it's going to continually spread out, eventually encompassing all values. When we talk about the range though, and let me zoom right in, the range, we always talk about the minimum y value, which in this case is 0. And 0 falls right on the line of that function. All right? So the range here is part of that function. We start at 0 and we go all the way up to infinity. So we have to put a hard bracket on that 0 because that 0, that endpoint, is part of the function. So again, it goes back to the whole idea of interval notation. If I go back to Word, negative 3 to 4, this endpoint, 4, is part of that function. Okay? Same thing with a line, right? So if we're talking here at 0, 0, 0, 0. The range of this thing, the range, would equal hard bracket on 0 all the way to infinity. Infinity never gets a hard bracket because it never really ends. All right? So that's the next kind of point I just want to make. If it's part of a graph, it's the same idea, right? If we have these things that are part of the function, use a hard bracket. If they're not really part of the function, or we're just generally describing the behavior of a graph, it's all good. Just use soft brackets. The last thing I want to talk about is piecewise functions. And these ones are really kind of strange when we're starting to explore things like, intervals and whatnot. So it's going to be negative 3x if x is less than or equal to 0, and it's going to be negative 4 if x is greater than 0. Okay, so what we can do here is we can sketch this graph out. I'm going to do it a little bit dirty here just because Desmos is kind of complicated to graph all this stuff. But let's pick a few points here. So I know that x has to be less than 0. So if x was 0, I'm going to get a point right here at 0 and 0. So let me get a different color out here. All right, let's get some red going. Okay, so 0 and 0. So my first part here, if x is equal to 0, and I sub that in, it's going to be negative 3 times 0, which is 0. So there's my point at 0, 0. The next point I'm going to pick is negative 1, because I have to pick a value of x less than or equal to 0. So I'm going to pick negative 1. So f of negative 1 is going to equal negative 3 times negative 1, which is 3. So I'm at negative 1 and 3. So I'd be somewhere around here. Right? And there's my line right there. Boom, it's going to keep going. Now this next part, for all values of x greater than 0, it's going to be negative 4. So let's say negative 4 is down here. Again, it has to be greater than 0, so I'm going to use a hollow point there, and I'm going to draw my line horizontally. Okay? So there it is. I graphed the first part, I graphed the second part, just paying attention to the values of x and going from there. So let's come up with the range. This is a common question on these. So as I move from the most negative y value up, I encounter negative 4, and that's really just one value. So I'm just going to put that inside a set of braces. Okay? That's not like an interval or nothing like that. It's really just one point. That's all that's saying. So for any value bigger than 0, we get negative 4. That's it. There's no variable there. There's no range of values. Nothing like that at all. Okay, so just put that in a set of braces using the roster method, really. It's one point. And my union symbol. And we're going to have this interval. So it starts here at 0. Okay, it goes from 0 up forever. So it's going to go from 0 to infinity. But notice that 0 falls right smack dab on that dot. It's part of this piece of the function. So again, we're going to use a 0 with hard brackets, and we'll go to infinity with small brackets. Okay, so I hope that kind of helps summarize things together. The big idea, hard brackets, if the value falls within the function, whether it be a graph or an interval or anything like that, a number line, if it falls within the function, you're going to use hard brackets. If you're talking in general terms about whether a function is increasing, decreasing, or whatnot, soft brackets. Because again, unless it really falls on that value, which I doubt it will, except for an instant, but again, that kind of butts up against calculus, you can use soft brackets when you're just generally describing what's going on, increasing, decreasing, constant. And lastly, for piecewise functions, it's the same play, right? So if, again, doesn't matter if it's the piece, whatever piece you're graphing, if the range or the domain fall within values of that function, use hard brackets. So that's kind of my take on it. I hope that was helpful. Let me know if you have any questions.